All right, section 1.1, Introduction to Logic. We got these topics, and I'm just only going to hit a few things in this, just kind of run through some stuff. These are the truth tables that you want to write down and keep these really handy and next to you. So conjunction, disjunction, conditional. So statements, statements versus not a statement, is defined as a declarative sentence. It's either true or false. I'm going to let you dig through those, ask any questions if you have. We've got a couple other slides on here that you can kind of work through. What I wanted to do is more so just kind of talk about like specific things. So if you have specific questions about anything here in the slideshow, please reach out and let me know. But I tried to build the presentation so that we had like these representations. So here's some symbols. So when we talk about our types of statements that we can make is we have a conjunction statement, which is an and that symbol will be used. A disjunction is or, and the upside down will be used, and then not is a negation, that'll be the tilde. So when we negate things, basically we're just like, if it's true, it becomes false. If it's false, it becomes true. So like two negatives make a positive kind of idea. So in a truth table, if we had P and P could be true, you negate it, be false, and so forth and so on. Got some examples. And then we got some like quantifiers. So like if you negate the statement all do, then some do not. And that's like super confusing. So like the more better is like write that down in your notes. If it pops up, then you got it. Some do, then none do. So it's kind of a confusing situation because you're thinking like if all, then the negation of that would be like, nobody, but it's not quite that clear cut. Some do not when we negate that. Got some examples for you to play around with. Kind of read those over, and then we'll practice them in our homework. A couple more. And then we've got like some symbol stuff and kind of talk about. So then this is what the video I really want to talk about here is like compound statements. So with compound statements, we have and, or, not, and, if, then. So we'll kind of jump into those right away. So we're going to start with the compound statements. Like, for example, if Amanda said it, then it must be true. This statement is a compound because it's an if-then statement. So you've got if this happens, then this happens. Whereas here, the second one, the gun was made by Smith & Wesson. There's no like the gun was made by Smith & Wesson and it did something, or the gun was made by Smith & Wesson or it did something. So it's not an if-then statement. So this would not be a compound statement because a compound would be where you have an and separating the two statements, an or separating, a not, or an if-then. So compound just basically meaning like two or more statements. So let's get deeper into that compound thing. It's pretty straightforward. So with truth tables, those pop up and you saw them at the beginning, we had to have some type of compound statement. So I want to kind of run through. So conjunctions. In a conjunction, basically what happens is like they both have to be. And so we got some definitions and so forth we can take a look at. But I think the truth table is like the best thing to think about. So like the whole idea with a conjunction, it's an and statement. So think about it this way. If you have P, sorry about that. If you have P and P is true, and you have T or Q and Q is true, then both are true. So therefore P and Q is going to be true. If you have P is true, Q is false, one of them's true, one of them's false, so the false overrides it. So if they're not both true, then in a conjunction, then the statement's going to be false. Next one, so if we had false, true, that's still going to be false, and false will give you a false. So we've got some examples here in words to kind of help understand. So you're saying like in the second one, for example, 2 plus 3 is 5, and 4 is less than 2. So in order for this overall compound statement to be true, they both have to be true because it's an and statement. P has to be true, and has to be true. And Q has to be true in order for the overall compound statement to be true. But in this case here, that's not what's happening. So we have a false statement. All right. So as we move along, we've got some examples. You can kind of read through there and mess around with those. We get disjunctions. So disjunctions are or statements. So in this case here, when we make a truth table of an or statement, we have P can be true or Q can be true. So therefore P or Q is true. Or T is true. So we have T is true. Q's false, but one of them's true, so the overall statement is true. Next one, P is false, T is true, so one of them is true, so the overall statement is true. And the last one, a false and a false gives me a false, because they're both false, so overall it's going to be false. Got another example of a disjunction. So constructing a truth table. So this is kind of like a piece that I want to like take a look at and try to make sure we understand. When we make a truth table, what happens is we build our way across the truth table. So to be able to get to this compound statement over here, what we need to think about is like how do we get there? Well, we've got to build it up. We got to start off with P and Q. So we build our basic truth table. So true, true. So basically every time I set it up, I do true, true, false, false. I do true, false, true, false. So that's how I set up every time. So then I have a combination where I'm looking at both of them are true. One's true, the other one's false. Or P's true, Q's false. P is false, Q is true, and then they're both false. So just if you just set it up the same way every time, so T, T, F, F, T, F, T, F, then every time you get every combination possible. So we're trying to work across to this statement right here. To get there, we see that in the statement we have a not P and a not Q. So when we break this down, that means that the reason that we have this statement right here is because that's a part of this statement at the end. And then we have, we know we had to have a not to get to this statement. We had to have a not P and a not Q to be able to get that. So then what happens is I apply my rules of disjunction. So now I'm only looking at these two guys right here. I'm only looking at this. So I'm done with this. Those have served my purpose. I negated my P and Q and got my negations here in these two columns. So now I'm going to apply the disjunction. So I'm going this way. So false and false gives me a false. So there's a disjunction. It's an or statement. False or true gives me a true because one of them is true. True or false gives me a true because one of them is true. And a true gives me a true because they're both true. All right, so I'm going to clean this up real quickly because I kind of want to make sure that I have a little more room to kind of build up. Now, my next one to get to this statement, I'm going to take this guy and put them together because that's what I have right here. I have this not P or not Q, not P or not Q. So now in this problem, I will now, in this part of the truth table, I'll be taking this truth value and that truth value, and it's a conjunction because it's separated by the and. So true and false, so true and false is going to be a false. On the next one, I have a true, so I'm taking this one and this one. So it's a conjunction, so I'm looking at that, so I'm putting them together. So I have true and true, so true and, sorry about that, I'm just going to go with that for now. So true and true gives me that. On the first one, it was true and false. So I'm just kind of piecing together what this statement right here is. The next one, I'm going to take the false and the true and put them together. So I'm going to have a false and a true. So this is a conjunction. They both have to be true to get a true. So instead I get a false. On the last one, I get a false and a true. So just like the one above it. So a false and a true gives me a false. So the initial thing kind of here is how do we build out a truth table and making sure that we understand that part. All right. Let me clear that selection. There we go. All right, cruising down. So we've got some when we have words. You're still with this. You're still going to make a truth table. The difference is that we're sitting here and they're saying that this is my P value. So that's my P, and then this is my Q. So essentially what I'm looking at here is I'm saying, like on this one, I'm saying, it is raining, or, because it's a disjunction, or it is March. And so we still make a truth table for this. I mean, you don't just like guess your way through this, but the idea is that, what would be the solution? Like all we're doing here is just like writing out the statement. So it's either this or it is March. On the next one, it's the negation of that. So in this case here, it would be it is raining and it is March, but it's a negation. So it is not the case that it's raining and it is March. So it's like we're just negating the overall statement. All right, cruising along. So this is a quick summary just of like the different tooth pouts. So summary for truth tables, negation, conjunction, and disjunction. So use this video here to kind of help work through the section 1.1 homework assignment. Let me know if you have any questions and we can kind of build out some more.